Hello everybody, in this video I will show you how to define ideal NMOS model in LTSpice. So first of all, we select our component, this is NMOS here in the library, we place it here, and then we do Control right button and we change this name here. I already done this with this model in my circuit. I call it NMOS underscore X, and then I find here my directive for the component. So I have my dot model, the name of this instance, and MOS is the family of device, and then here I define the threshold current with 2 volt, the transconductance parameter. It depends if you're using the transconductance formula or the conduction parameter formula. See the comment below. And in my case, it's 1 milliampere for volt square, the conduction parameter. And then lambda equals 0, which is basically it states that the model, the NMOS is ideal, and the current ED, the drain current, has no dependence on the voltage between drain and source. So I build up this simple circuit with a battery here, resistors, battery. And then I first launch a simple simulation operating point. And if I do my calculation with my mesh and stuff, I see that for an ideal NMOS with this parameter, I should have 1 milliampere current. So I have what I want. And then also I can check the behavior at different values of VDS. So I comment this directive here, and I delete actually this one, and then I uncomment this one, which is basically, I will show you. Oh yeah, so let me do this well. So I have in my simulation, I have 2 voltage source. The first one is V1, which is the drain source voltage, and then which I move between 0 and 6 volt with 0, 1 step, and then second voltage source, which is my gate source voltage, and I move this between 2.5 and 3.5 volt, so above the threshold current, and with this 0.5 25 step. So I run the simulation and I plot now the drain current, and with this I have the typical graph of NMOS transistor. Thank you for watching. I hope this could help. More details in the first comment of the video.